Hello, everyone. Today, let's learn about the design of general road subgrade as part of the subgrade structural drawing, design, and interpretation content. First, let's understand what a general subgrade is. A general subgrade refers to a subgrade constructed under good geological and hydrological conditions, where the fill height or excavation depth does not exceed the limits allowed by the standards. It only requires the use of typical cross-sectional drawings or design specifications directly, without the need for demonstration and verification calculations. A special subgrade refers to a subgrade under special hydrogeological conditions, where the filling and excavation have exceeded the standard limits and must be designed and verified to ensure strength and stability. Next, let's learn about the types of subgrades. An embankment is a strip-shaped structure filled with soil or stone on the natural ground surface, which meets certain technical specifications. Embankments, based on fill height, can be divided into low embankments, general embankments, and high embankments. Low embankments are generally suitable for flat areas or areas where it is difficult to source soil, requiring the natural ground's upper soil layer and the embankment to be fully compacted to meet the working area's requirements. High embankments have a particularly large earthwork calculation, occupy much space, and have poor driving conditions. Embankments can be classified into immersible embankments, tow protection embankments, and trench-filled embankments based on the conditions they are in and the type of reinforcement. A general embankment may have borrow pits on one or both sides, and a berm not less than 1 meter wide must be set between the borrow pit and the embankment slope foot. The role of the berm is to protect the fill slope foot from water erosion and keep the fill slope stable. An immersible embankment refers to an embankment on one or both sides subject to long-term or short-term submersion, where the berm width must be at least 4 meters. A broken line-shaped slope can also be used to reduce river erosion on the slope. As embankments have good ventilation, convenient drainage, and are manually or mechanically layered, the properties and compaction level of the fill can be controlled as required, which is a commonly used form in engineering. A cut is an excavation subgrade lower than the original ground surface. The most typical cut is a full excavation cut. Gutters are needed on both sides of the subgrade. Depending on the soil quality, a broken line-shaped slope can be used, with catchwater drains required above the slope, not less than 5 meters from the top. At the slope foot, a debris platform is needed, and when the slope is prone to weathering, protective measures may be taken. The left image shows a benched cut, where the road center line should be moved inward to avoid a small amount of filling on the outside of the subgrade. The right image shows a half-tunnel cut, which can be used to save on rock work while ensuring safety and reliability if a solid rock layer is encountered. Cuts have poor drainage and ventilation, poor driving sight distance, and disrupt the natural balance of the original ground surface, being highly influenced by hydrogeological conditions. The excavation slope needs to be set based on the height and geological layer conditions, forming straight, broken, or step shapes, and choosing the appropriate slope rate based on geological and hydrological conditions. Thus, in cut design, geological and hydrological conditions need attention, and cut should not be constructed under poor geological conditions. Catchwater drains should be set in advance at the top of the slope. A half-fill, half-cut subgrade refers to a cross-section partly consisting of an embankment and partly a cut. On a slope-based subgrade, usually the elevation at the center of the road is close to the original ground elevation to reduce the quantity of earth and stone and maintain lateral balance. If handled properly, the subgrade is stable and reliable, and this cross-sectional form is economical. The excavated part of the subgrade consists of undisturbed soil, and the filled part consists of disturbed soil, often with different compaction levels. If not handled properly, longitudinal cracks may appear at the fill excavation interface, or slipping along the foundation base may occur. When the original ground's cross slope is greater than 1 to 5, to increase the stability of the fill portion, step excavation on the original ground must be performed before embankment construction. When the cross slope is greater than 1 to 2, it can lead to excessive filling or an inability to fill, and supporting structures like shoulders and retaining walls may be constructed accordingly to form various half-fill, half-excavation subgrades. A zero-fill, zero-cut subgrade refers to when the ground is flat and the design elevation of the route is equal to the ground elevation. Almost no fill or cut for the subgrade occurs. Although this type of subgrade can save on earth and stonework, it is very disadvantageous for drainage, and often the undisturbed soil's compaction does not meet requirements, easily leading to subgrade diseases. Hence, it is best to use it less or not at all. That's all for today's class. Thank you.